Hello and welcome to my YouTube channel. Today we are going to start a new playlist, or we can say a new course, in which I will try to cover real-time operating systems using free RTOS. I will try my best to cover all the important concepts and fundamentals related to real-time operating systems. Apart from that, this course will cover hands-on experiments to visualize and implement the concepts related to FreeRTOS in real world. So let's start the video. First of all, let us start with the introduction part. So let us talk about introduction to RTOS in embedded systems. What is an operating system? Because RTOS is a part of operating system, real-time operating system. So it comes under the umbrella of operating systems. So how can we define an operating system? So basically, operating system is a piece of software. Remember, it is a piece of software that ensures the operation of different hardware inside a computing device and is responsible for interaction between hardware and applications. When we say hardware, so let me just briefly talk about the hardware that can be controlled or that are actually handled using operating systems. So suppose we have a computer. In the computer we have a CPU. Okay, in the CPU we have power supply. Okay, power supply. Apart from that, we have the processor, main processor. Then we have RAM. We have other memories like external hard disk, HDD, and so on. So operating system basically provides or ensures the operation of all these peripherals in a proper way, and all the features related to these hardware are controlled and managed by the software, which is called operating system. Now it also manages the smooth running of all the functionalities of CPU, memory, and peripheral devices of a computing device. Even it controls all the peripherals within a CPU. Within a CPU means within the processor. So in a processor you can have RAM, you can have ROM. Okay, for example, if I am talking about a CPU, okay, so there are two ways we can visualize a CPU. One, the CPU in which you have the SMPS which handles the power supply and all, and then we have in the core a microprocessor, we have RAM, okay, and we have HDD and so on. So here what I'm saying is, inside the microprocessor also there may be several peripherals which are actually managed by the microprocessor. So even operating system handles the peripherals which are inside the microprocessors, like several registers are there, several cache related memories are there, and so on. Now operating system also mediates between the used and the computing devices, okay, and provides user interface for services of all applications. So basically when we say applications, so taking an example, for example, we have Microsoft Word, Excel, okay, and so on. So we have several applications which are actually installed in a computer, and they are also managed by the operating system. So operating system provides an interface to handle all these softwares and optimize the usage of the hardware, okay, inside a computer. It also handles multitasking, because now we can say that there are so many computers which can handle multitasking related applications. So operating systems now can handle multitasking to save time and resources of the computer. For example, there are several operating systems available in the market. Most commonly used operating systems are Microsoft Windows, Apple's Mac OS, Linux, Android, generally used for mobile phones and all, and then Solaris, and there are several other such operating systems which are actually handled or used by users in day to day life. Now the question comes, what is real time system? Because when we are going to study about real time operating system and we have defined what is operating system, then the question comes, what is real time system for which we need an operating system? So any system that has deterministic response to a given event are called real time systems. So deterministic response means, suppose I triggered a switch. Okay, I triggered a switch at time t equal to 0, and I want a function related to this switch to be executed or completed within t plus 5 millisecond. So this, if the event or if this function, okay, if this function completes within this time period t plus 5 millisecond, then I will say it is a deterministic function, because this function has been completed within a particular determined time. So any system which has a deterministic response to a given event can be called real time. Real time system is considered to fail if it does not meet the timing requirement. Here in this system, time is more important rather than completing more and more tasks. Here we have to keep an eye on the time. If the time or if the function completes within a specified time period which is determined by the user, then it is called real time. Now, what are the requirements of an real time system? So real time systems requirement can vary widely depending on the user, both in terms of speed of the timing requirement and severity of consequences. Let me go to the term severity of consequences and speed of timing, because these two are again a very important feature related to real time systems. So the term real time system refers to any information processing system like computer with hardware and software components that perform real time application functions. Again, real time application functions means deterministic functions which can be completed within a time or within a specified time period. So for more information, you can go to the links provided here. Okay. Remember, now by 2025, it is estimated that there will be 79.4 zettabyte of data created, and nearly 30% of it will be in real time processing. Okay, so out of these humongous data, 30% of the data will require real time processing. So there is a huge market which is open for real time operating systems, and the reference, you can go for the reference in the provided link. Now coming to the benefits of the real time systems and their applications. So first of all, real time operating systems provide very precise timing. Okay, so such systems will generate an output within a specified time period or we can say within precise cycle deadlines. It can even provide your outputs within microseconds. Second, such systems have very high predictability and reliability. Because the real-time system processes data in a defined and predefined time frames, so execution of functions or tasks are practically guaranteed. So they will never fail to provide the output within a prescribed time period. Third, we can prioritize the real-time workload. That means we can have different types of tasks and we can have different priorities for this task which will be executed within a particular time period. So these kind of systems firstly provide very precise timing. They are very predictable in response to the time. They are very reliable. They generally do not fail in any condition. And third, they have multiple priorities for multiple tasks, and according to which they will give resources and time to these tasks. And how we can classify different operating systems? First of all, we can classify operating systems or embedded systems based on their functionalities. For example, dedicated and general purpose systems. Dedicated systems are designed for a very specific task. For example, digital watches. Digital watches are designed only to provide you timing related data. Washing machines. They are again designed for cleaning the clothes. Secondly, general purpose system, which can provide you several different tasks or a range of tasks. For example, smartphones or tablets. So using smartphones and tablets, you can install several applications, and based on that you can use the smartphone for different purposes. For example, someone can use it for calculator, someone can use it for making calls, someone may use it for playing games. So one per device can give you several different options to use them, and such systems are called general purpose systems. And now, based on the performance, so real time systems, so in this case the output should be generated within a specified time frame. For any input, the output should be generated within a prescribed or specified time frame. For example, aircraft control systems, industrial robots, they cannot miss events even of milliseconds or microseconds. Then we have hard real-time systems, which are very critical tasks and they have very strict deadlines, even stricter than normal real-time systems. For example, medical devices like pacemaker. We cannot have a pacemaker which can stop working for 2 or 3 minutes and then it starts working. So in such cases, we have to have real-time, hard real-time systems. Here the hard word is important, and we have to meet the deadlines in a very strict manner. Then we have soft real-time systems, where sometimes we can miss some of the timing related events, or we can miss the time frames. For example, playing video games or browsing of internet. In that case, you may miss some of the frames, you may miss maybe some milliseconds for browsing, and that will not cause any harm to the user. Such systems are called soft real-time systems. Then we have non-real-time systems where timing is not that important. For example, home appliances like your toasters or your washing machine or something like that, where It is not necessary that the system should generate an output within a millisecond or within a microsecond period. Okay, so there we can have some freedom of time period. So based on the performance, we can have real-time systems, hard real-time systems, soft real-time system, and non-real-time systems. Now, further, to classify the embedded systems, we can have classification based on the complexity of the embedded system. For example, simple embedded system, where the basic functionality is to process that output, okay, using a very simple limited processing power. For example, digital thermometers. They are simple to design, simple to implement, and have a very basic functionality and limited processing. Second, complex embedded systems like automobile or automotive control systems, complex industrial machines, and so on. Further, we can classify the embedded systems based on the applications. For example, consumer electronics like televisions, gaming consoles, digital camera, and so on. Automotive systems which are dedicated for automotive or automobiles, which includes navigation system, engine control systems, advanced driver assistance system, and so on. Then further, based on application, we can have industrial control systems, which may include controlling of the machines installed in the company, monitoring systems, and automation equipments which are installed in an industry. Generally, in these cases, we use PLCs, programmable logical controls. Last but not the least, medical devices, which include diagnostic machines, patient monitoring systems, infusion pumps, ventilators, and so on. So based on the applications, we can further classify embedded systems as consumer electronics, automotive systems, industrial control system, medical system, and so on. And lastly, we can classify the embedded systems based on the development platform. When we say development platform, then we are talking about the hardware which are used to design or develop those embedded systems, mostly based on microcontrollers or microprocessors. So microcontroller based systems may use microcontrollers like Atmel's Atmega 328, which is generally used in Arduino boards and all, PIC based microcontrollers, STM32 based microcontrollers, or Texas Instruments TM4C123GH6PM microcontrollers. There are so many other microcontrollers available. Secondly, based on microprocessors, in which you can use embedded PCs containing Intel's microprocessors or AMD or any other similar microprocessors. So this is how all the embedded system and real-time systems are differentiated. And this completes the introduction part. If you have any queries or suggestions, please use the comment section to provide your or to give your suggestions and comments. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you can be notified as soon as I upload a new video. Thank you and have a nice day.